the aim of this meeting, of this presentation is, I don't want to copy paste the Google. I mean, it's deep, it's a lot of information out there, you can do this. What I would like to achieve, that when I finish and we will go home, all of us will understand that some certain things like subqueries, CTEs, indexes exist, and what they could bring me, how to play with them, and don't be afraid to try, because I remember when I started my journey with SQL, and it was like I was confident to start that from queries. Otherwise, I thought I will do some multiple or Cartesian join, I will break something, but it's not true. Or if it's true, most likely your DB admin will cover you. So we've got this great meme where you don't have to be aware to delete your my computer icon and put it to the bin, because it will not disappear. Don't worry, it's not that bad. Unless you're using delete, truncate, drop comments. If not, just be aware what we've got, what are the possibilities, and try. Because as you will see, there is no direct answer that something will work better than the other always. Everything depends on the structure and how you use it and for the particular case. So moving to the agenda, we will discuss, we will be focusing on some analytical problems, like how to build query and do it from the very beginning, architect the structure of your query in the efficient way. I mean, there are two ways how we will look at it. So, I mean, first one is, okay, I'm creating something from the scratches, but also you could face off some issues like you're joining new company, you get some legacy queries from your predecessors and you have to deal something with them. And yeah, by knowing the structure, you could also start playing, checking bottlenecks, maybe restructurize it a little bit, depends how it goes. So we will start from the design concept in a nutshell. Then we will go to query execution plans, because that could spot us some places where we will have some bottlenecks, or where our query stocks something and where we could start our problem solving. And as a cherry on top, we will said a little bit about indexes. So there are some cases where by creating good index, it's enough. I mean, even if query is partially designed correctly, it will speed up it significantly. So this is quite important and fun part in terms of optimization, but we're gonna do that. And yeah, all of that we will try to cover in our exercise part. Thank you, Abda. So let's start from the differences of subqueries, CTEs, and temp tables. In a nutshell, as I said, we'll start talking about the design query itself. There are various ways to do that. And I think, and one disclaimer, we are not talking about the query when we have select tag from and live join. Not about that. More complex. Because when your position will be more mature, you will face off some queries who generates really complex report, and it could have a couple thousand or a couple hundred lines of code. And each of this query could be built in some certain ways, most likely one of them. If we go to let's think about it and explain it based on some certain example. What are subqueries? Subqueries are the nested queries, so basically there are queries in the queries. We're using them in select, where, join statements, from as well. So this is those nested queries are stored in they're creating a table, sub1, which is stored in the query itself, and it's available only during executing this query. So once the query will be done, table is done. And maybe we could, that would be the main principle of that lecture. I would like to put some examples, maybe for you to have a better understanding. How the structure of subquery look like and how how it could be designed. So let's say that we have X company and X company have a table A. Within we have a customer, country code, and 50 other columns. On the other hand, we have a table where we have location, where we have country code, and country name, and 20 other columns like, I don't know, continents, some coordinates, geographical one, stuff like that. Our manager come to us and said, to tell us to create a super simple report of customer and country name. We could do it in a simple way, like we could just do select a customer, B country name from A as A, and left join B, or location. Right? What we are doing here? Here we are joining all this table into this table, which by itself it's not efficient. So in the nutshell, we can speed up it even on that level by using subquery. Instead of putting location table and in the left join, we can put select country code and country name from location. This, at the very beginning, narrows us that table, and SQL server engine will not be joining all those columns in that operation, which ultimately speed up our request. And this is super easy example how to use subqueries. If we go to CTEs, they have some special word with it, which is with, and with that, we could creating complex queries which are working by itself in a similar way to subqueries, because the tables are also created temporarily, and when the query will be executed is gone. However, with the with statement, we could put some tables aside our query, and if we are doing it, if we're joining them multiple times, that will be more efficient. Let's see example. Let's say that our company X has two entities, A and B. And table B contains customer, country code, and 33 different columns which are not exactly the same as that one. And I already said, at the beginning I'm saying this is dummy example, but we will see how it goes. If our manager comes to us and tells us, okay, show me all customers with the country, all customers with their country name for both entities as a one report. We have already that one. So what we will do, most likely, we will create exactly the same query. That would be the easiest one for a B company, B entity. And maybe we will union them, right? But already we see some not efficient operation, which when we are talking about query optimization is very important rule. So don't repeat yourself, because with that, we again, most likely to save some server spool, we will create another one, same subquery second time, because anyway, we will be using that dictionary. So, with statement allows us to pull that request on top and then create the report by joining this table twice. Once query will be finished, executed, everything will be done, but this operation will happen once. We will see it on the next slide when I will show you how the with statement look like and how it's constructed. And so that's the main differences. So also with, for the very complex queries, will improve your code readability if it comes to subqueries. Moving to temp tables. So these are, later we will move there. Thank you. Moving to temp tables. So these are completely different objects. These are, they perform and behave like normal tables. Apart that, they are kept in the TempDB, which is some system separate database. And for that purpose, we can query those tables exactly like a normal tables. So if we think about it, backing to our example, we could narrow our location table by taking only those two columns and creating separate table, which is with us, staying, and we can use it until we close our session. It's it's on the server memory, and with that we could join that tables many times to many entities as well, as we will be joining just a location table without any unnecessary fields. How it goes if we compare it to CTE, we can imagine that if our code will have 3,000 lines of code, CTE is performing once, and this code will perform constantly without anything, and once it will be executed, it will be done. In temp tables, we have, I think, two advantages on that. We can slice and dice. So if something is running, or we are constantly, we're on the couple steps joining same table, we could do this also as a temporary table, and when we don't need it for a further execution, we can drop the table, which release our server memory. And there is another benefit which I see in temp tables for a more complex query, which is it's easier to validate your query, because if you can imagine, with CTEs with 3,000 lines of code, you need to take those select, I don't know, either group by, put another comments, somehow redesign them. Temp tables is a table. You can select it as it would be a normal object. In MSQL, we differentiate two temp tables, two kind of temp tables. So one is local, and this is something we are creating it by adding hash at the very beginning. It's this temp table, it's gone. It's once you close your session. And the difference between local and global is when you create a global temp table, all users, other users can use it until all session will be killed. Thank you. And as I mentioned, we have some examples of the code. So as we can see on the subqueries, it's something more like we built here, with as a set. Select some tables are pulled out from the general subquery structure, and then we can join them at the very end, for example. And temp tables, which in fact each of those creating separate tables, and we can query on them as there will be normal tables until our session is over. Next slide, please. So Summarizing the usage and I think the preferences of using them is yeah, I think subqueries are quite good if it comes to non-complex queries, and we have to bear in mind that during execution all actions are stored in memory. CTE works in similar way, but code readability is better, as well as they improve our performance if we joining same table a couple of times. In terms of temp tables, yeah, for multiple processing passes on a set of data, I think they are better. Better when amount of data gets too big, it's out of handy. You would like to maybe partition your query, not doing everything in one shot, and as well as it's better to validate them. And this is very general description, because really this is something which depends how you design your query, and you need to try. For some certain queries, depending on the report, one will work better than the other. So this is something where you could face off, as I said at the very beginning, in your work, as a legacy for your predecessor, so on. With that, at least I hope you will be able to understand what's going on and be able to play with it and try to suit best solution possible. Execution plan. So once we have the query, no matter if we build the structure, if it's given to us, we have some tools in the server which allows us to check what are the potential bottlenecks could be, plus describes how many memory, how many assets server used for some such particular task during the execution. And how it looks, we have graphical way, we have table way. Put that here. We will see all of them during our exercise. I put that one. I think it's super readable. So on the left-hand side, I make it readable. You can imagine that this is the first part of the table. We have nodes. So it's structured. The top node is a whole query, and the lowest one are the subqueries or other actions which server did before complete whole query. How it looks like in terms of measures. So we've got timings, and we have exclusive and inclusive. Exclusive one means how much time server spent on that particular task. Inclusive is how much the time he spent to generate everything until that point. So it's basically the sum of everything which is at the very end sum up to generate that query. Regarding rows, also execution plan built based on the assets on the server, built a roadmap, and he predict how many rows we should have as an output of that query. And on the other hand, we have how many we get. So this is planned and actual, where rows X is the error, which so the amount, so multiplication, those two of error. So this he did mistake by 55 times almost in that particular case. Loops, how many times server run that particular task. So as we can see, 3, 3, 1. That's how it looks here. We'll go through it also during our exercise. And the third part, so once we spot what is bad or what could be our potential bottleneck, once we maybe play a little bit with the structure, we are sure that we are not repeat ourselves, we could also start to put some additional boosters on our queries, because I think we can name indexes like that. Because what is index? Index are the objects which are given to us, especially to boost performance our query. That's their main goal. And if we are talking about the indexes in MSQL. We diversificate indexes into two parts: clustered and non-clustered. And I think to explain that, we can use I think very famous book example, which we also find in internet, but it's good really and understandable. So let's think that way. Let's think about server as a book, and let's take Harry Potter. Harry Potter is good. So we have a Harry Potter book. How the Harry Potter book is constructed? So we have at the very beginning we have table of contents, where we have description of where each chapter starts, on which page are ordered, so on. So we've got that. Then we have the actual book. So we have each page is ordered by numbers, works like that. And at the very end, or even as a add-in, we have a workbook or appending, whatever we call, where, for example, we store the data about some particular things or particular actions within the book. And let's go through the example. Let's say that I would like to browse or check the chapter where Harry Potter arrives to Hogwarts. I'm going to table of contents. I'm browsing it, 3 pages. I see, yeah, it's page number 50. I'm going to page number 50, find it immediately. We can imagine that this is very similar or a way how clustered index works. So clustered index is also something ordered, is also something which tells the server where to find those exact points, those exact pages or chapters, right? Because they are numeric, they are ordered. That's the things which clustered index have. Plus, we can also imagine that default clustered index on each table is primary key. It's not like that. It always has to be like that, but in general, when we are creating primary key with a constraint function, we're also creating default clustered index. And exactly like in the book, the clustered index on the table could be only one, and it is stored on the server. So we are not buying usually separate table of contents plus book, but it's all together, and they are connected. Moving to non-clustered index, let's think that okay, we know where we find the information when Harry arrives to Hogwarts, but we would like to also have some information about Hermione. I don't know, we just all of them, right? So we're going to appendings on book of contents, and we see that under the Hermione information are on the pages, and we have the list of pages where such information exists. And now we can, for example, we are very into her potion classes, so we can browse all of pages where Hermione exists or is in the book, and that speed up our finding that information instead of reading whole book. And that's how non-clustered index works. Easiest example, because we have only one point, one spot where we ask clustered index to tell us something, which is Hermione only. However, non-clustered index could be also multiple words. So, for example, we could create clustered index with Hermione and lower leaf level where we spot, okay, let's point us also her classes in general, and our appendings will look like Hermione classes, potion, spells, something else, and we will know exactly where the potion classes are in the book. We have to do the same, but the lower leaf will navigate us better. With that, we can say that non-clustered index could be multiple not clustered index in the one table. We are not limited to one. It's not has to be ordered in any way. We could add additional leaves under that, which spot us the place better. And they are not stored in the table. They are stored in TempDB, so it's a separate object. They are not part of the table itself. So I'll include you. And moving forward, that's how instructions to create indexes look like. So clustered index, it's just we are providing, it's by create clustered index statement, index name, on, table name, and which field it will be. Regarding non-clustered, schema is exactly the same. If we want to add some some lower leaves, we're putting include statement. And for example, in that particular way, we have company name, sales representative, or sales region. And if we ask database, if we ask server for exactly those three, combination of those three fields, he will refer to that index and quickly find the spots where that combination exists in the table. Okay, thank you. So, conclusion. Indexes are used to speed up the query, resulting in high performance. And we've got a starter, because as I said at the very beginning, these are the objects who should support you with that and will support you with that. But there is a star. They have to be created correctly. I mean, you can play. You should play. You should try to do different indexes and check how they perform on the database. But you have to also bear in mind that that could slow down some operations, because indexes are connected with the table, and once we build something, index, and for example, we set up index on the table, we have to bear in mind that if the table changes, index also has to change. So all those statements like insert, like like alter, so adding something additional to the table will take longer. So it's a great solution for analysts, I guess, because we are using mostly tables to create reports, to do reads, to extract the data from them. If you have a table which is static, which is not frequently refreshed, and you have some complex indexes out there, it may be work for you. On the other hand, if you put too many indexes, it will also it could stock the process of refreshing and be completely not usable for you during creating your report. So this is something where we've got possibilities. You need to play, you need to check, you need to do some magic. Check the execution plan afterwards, see how servers see the path, what he is taken to execute the query. So, as I said, quickly wrapping up, working on similar pattern as textbook indexes, one clustered index per table, multiple non-clustered index per table, and clustered index, it's stored within table, non-clustered not.